an example maps with don't care. Now let's look at an example expression. Let's say we have f of a function contains three variables a, b, c that is given by this expression. Summation sign m and then 0, 2, 6, 7 plus sigma d 1, 3. And here you know that when we have a Boolean expression like this sigma m represents min term and this sigma d represents don't care. And if you want to express this one in a k map, it's gonna look like this. Here we have three variables, so 2 power 3 we are going to have 8 locations. Okay, so this is our 8 locations, and let's say we take the AB top and C on the bottom. This is 0, 0, 0, 1, 1, 1, 1, 0. This is 0 and 1, and this location is represents 0th location. This location represents first, and then 0, 1, 0 that is 2, 0, 1, 1 that is 3, 1, 0, 0 that is 4, 1, 0, 1 that's equal to 5, and then 1, 1, 0 that is equal to 1, 1, 0 is 6, 1, 1, 1 is 7. Okay, these are the location, and according to the given information we have a 1 at 0 location, so we have 1 right here, and we have a 1 at 2 location, that is 2 right here, 2 right here, and we have a 1 at 6th location, that's right here, and then we have a 1 at 7th location, that is right here. Okay, and we have a don't care at one location, that is right here, and we have a don't care at 3, that is right here, and others are going to be 0. Now here the don't care is helpful if you can make the expression simpler. Like for example, let's say you want to write product of sum. So if you make x0 or x1, it's going to be helpful. And when we write expression of product of sum, we have to look at like how many maximum 1 we can combine. It's always 2 powers, like 2 power 0, 2 power 1, 2 power 2, 2 power 3. 2 power 3 is 8. 8 is better than 4, 4 is better than 2, 2 is better than 1. So 8 we don't have any possibilities, but 4 we have possibility. If I make this don't care 1, I can make it 4. But if I don't make this don't care 1, I can only connect them as 2 only, because we don't have ones in the square shape or longer, right? So we don't have any way to connect the ones ones together, like 4 of them. So let's actually look at it. Like let's say we assign 0 for this don't care. Let x is equal to 0 for both. If I make this one 0, what's going to be the expression? We are going to have this. We have to look at these two first. We can look at these two first. So for these two, a is not changing, so we put an a prime because a is 0, so I have to complement that to make it 1. And b is changing, b is 0, 1 is changing, so it's going to be eliminated, and c is remaining the same, but c is 0, so I had to do complement for it, c prime, and then I can connect these two together. If I connect these two, what's going to be the expression? A and b are not changing because a and b are remaining 1, so it's going to be not changing. A, b remains the same, and c is changing, c is 0 and 1, so c is changing, so it's going to be eliminated. So this is the expression if we have this don't care value is equal to 0. If we make this don't care value to be 1 for both of them, what possible way we can connect? If this is 1, we know that 4 is better than 2, so instead of connecting this as 2, I can make this as a 4, right? So I can connect this as 4. I don't have possibility of connecting this as 8, But the next thing is I can connect as 4. And this one also, instead of connecting as 2, I can make this one as 4 as well. That makes everything simpler, right? So let's look at the new expression. So if we connect that, then what's going to be the expression? Let's look at the first square we row. For that one, a is not changing, so a is going to be a prime, and b is changing, so it's going to be eliminated. C is changing, so it's going to be eliminated as well. So the expression is a prime. And for the second square we draw, a is changing, so it's going to be eliminated. B is not changing, so b is going to be there, and C is changing, so C is going to be eliminated. Now you can see this one is far more simpler than this one, right? This is the best one because this is very simple. So whenever you have a situation that if you take the don't care, that can make expression simple. It's only possible, like let's say the don't care is right here, then okay, even if that you can connect as 4. So I will draw another example where the don't care is not really helpful. Okay, here it's helpful because 4 is better than 2. If you can make it 4 and you can only connect 2s, and if you have 4 available, if you make the don't care 1, then you have to go for the 4 then 2, right? So this, if you have a situation like this is the way to do it. You have to make the don't care to 1 and you have to make it simpler like this. Okay, now let's look at another example. Okay, let's say we have an expression given like this: f of a, b, c, d. We have four input function given, that is min term 0, 3, 6, 9, and 11, 13, 14, and plus don't care, that is sigma d 5, 7, 10, 12. So here we have 4 input, so the number of location we are going to have is 2 power 4, that is 16. So we have to create a 16 location K map. Let's do that. So here we have a 16 location K map, and in this one we take the, let's take the top part as AB, and let's take the bottom part as CD, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. The next thing is the location. You know, you can look at this 0, 0, 0, 0, that represents 0, 0, 0, 0, 1, that represents 1, 0, 0, 1, 1, that represents 3, 0, 0, 1, 0, that represents 2, 0, 1, 0, 0, that represents 0, 1, 0, 0, that represents 4, 0, 1, 0, 1, that represents 5, 0, 1, 1, 1, that represents 7, 0, 1, 1, 0, that represents 6, 1, 1, 0, 0, that represents 9. No, 1, 1, 0, 0, that represents 12, 1, 1, 0, 1, that represents 13, 1, 1, 1, 1, that represents 15, 1, 1, 1, 0, that represents 14, 1, 0, 0, 0, that represents 8, 1, 0, 0, 1, that represents 9, 1, 0, 1, 1, that represents 11, and then 1, 0, 1, 0, that represents 1, 0, 1, 0, that represents 10. Okay, let's see if we have all the numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have all the numbers. Now let's plug the locations. So here we have, from the given information, the min terms are at 0. So at 0 we have a 1, at 3 we have a 1 right here, and then 6 we have a 1 right here, and then 9 we have a 1 right here, and then 11 we have a 1, 13 we have a 1, 14 we have a 1. Oh, and the don't cares are at 5, and then 7, and then 10. That's 10. Okay, so yeah, 12 right here. Okay, and the others are going to be 0. Okay, now let's look at this. Can I combine anything as 8 with kmap or without kmap? I mean, not with don't care or without don't care. So there's no possible way I can get an 8 combination. Like I cannot connect the 8 together at all. So there's no possible way. Can I connect 4 of them together? Because 8 is better than 4, 4 is better than 2, 2 is better than 1. So 8 we don't have it. The next question, can we connect 4 together? It seems like we don't have any location I can connect 4 together. So we'll leave it. We don't have any possibility of getting 4. The next thing is, what are the 2 things we can connect? Let's connect the 2 things. So I can first, don't worry about don't care until it's helpful. So here we already have 1. We take that one first. Let's do the expression. What is changing? Because a is 0 to 1, so it's changing, so it's going to be eliminated. B is 1, so it's not changing, it's going to be there. And C value, C and D value is same because it's in the same row. So C and D values are remaining the same. So we are going to have C, and D is 0, so I have to do complement for it. Okay. The next thing, can I connect anything else as 2? I'm seeing this one here. Okay, this one. What is changing? What's not changing? Is A is changing? A is not changing because 1 right here, so A is going to be there. B is changing, B is 1 0, so B is going to be eliminated. And then C and D is not going to be changed because it's in the same row, right? 0 1 all over. So C and D are not changing. C is 0, so I had to put a complement for it, and D is 1, so it's going to remain the same. Plus, do I have anything else I can connect as 2? I'm seeing these 2. Because you have to think, like when you have a K-map, you have to think like, if you fold it horizontally or vertically, can you connect something? For example, if you have a 1 right here and 1 on top, you can connect that one as well. If you have 1 on the left one and the right one, you can connect those 2 as well. So here I can connect these 2. If I do that, what is changing, what's not changing? A, and let's look at A and B. A is 1 here, 0 here. So A is changing, so it's going to be eliminated. Here B is 0, 0. So it's not changing, it's going to be there. B, and since it's 0, I have to do complement for it. And then C and D is not going to change because in the same row. So C and D is 1 1 all over. So C and D is going to be there. And that's it. And here we have just 1 left. Can I connect this one with anything? Can I connect with any other one or any other don't cares? I have no possible way of connecting this one with anything. So this one going to be alone. So the expression for this one is going to be A, B, C, D, but all of them are going to be complemented because 0 0 0 0. So all of them are going to be complemented. A, B, C, D prime. Okay. So this is the final expression. Here you can see we don't have any use for this don't care. If you have possibility of making 4 with this don't care, you have to go for that. And let's say if you have just 1 left, like this, for example, this condition, if you have 1 left and if you have a don't care, then it's helpful to use the don't care. But when you have a 1 next to it and don't care next to it, you have to go for the 1 first. You have to do the 1 first, and give the priority to the 1 instead of the don't care. That's all you have to know. And this is our final expression. And that's it for this video, guys. Thanks for watching. Don't forget to subscribe my channel. See you